Hey everyone, you ever wonder what they ask at Meta in order for you to get a job at one of these FANG companies? Today I'm gonna pretty much look at all the interview questions and just brainstorm how to solve them, but just also compile a list of all the things that people get asked at these companies, essentially. Or specifically Meta, and I'll do Google, Microsoft, what are the Netflix? Whatever the other fangs are? I already forgot what's an acronym. So let's look at. So I went on Discuss, and when I'm ever interviewing for a company, a lot of the times I just go on LeetCode here, and I hit the Discuss. Then I literally just search like Meta or whatever phone screen. And let's see what people are saying. You maybe newest to oldest is most relevant. Meta E4. What did this person get asked? Minimum remove to make up parentheses. Max consecutive ones. I'm just gonna store a list of this. Minimum remove to make up parentheses. What is this? Oh, this is a stack question. You pretty much figure out you're tasked to remove the minimum number of parentheses in any position so that resulting parentheses string is valid. So you pretty much use a stack to figure out the length of or the indices of invalid brackets, and after you parse the string and remove those invalid indices and return back the string afterwards, and that's the most optimal solution using a stack. There's other optimal solutions, but I think they're all the same kind of space complexity. O of n time, O of n space. So try to do this in O of n time, O of n space if you're interviewing. What's this other one? Max consecutive ones. What is this? Given a binary tree, or given a binary of nums and an integer k, return the maximum number of consecutive ones in the array if you can flip at most k zeros. Interesting. This is a sliding window technique. So you could do a sliding window technique, and you can grow. Yeah, you can pretty much do a sliding window technique where you grow the window up until you have until you have more than k zeros, and then you can reduce the number of zeros on the left side to shorten the window, and then continue extending. So it's a sliding window technique. That's an O of n time complexity, O of 1 memory. Let's see. Yeah. So that's a classic sliding window question. So a question not found on LeetCode's too easy. Can't remember. Some root to leaf numbers. What's this? So you're given the root, and I've done a ton of these questions because I've already implemented a lot of these. I've solved a lot of LeetCode questions over the last 3 years, so I see it's just right there. You're given the root of a binary tree containing zeros and nines only. For example, each root to leaf path in the tree represents a number. So a root to leaf path represents a number. Return the total sum of all the root to leaf paths. So yeah, I think this is a simple pre-order traversal. That's pretty much what I'm doing here. Let me delete this. You pretty much just keep a list of the digits that you've seen, and then when you get a leaf, pretty much what you do a pre-order traversal where you visit a node and you pop that into a path. Then if you're a leaf, then you actually join the path into a real digit and then add that to some total sum that you're maintaining. But pretend I'll add 4, 9, and 5 to the path, and and then once I get to a leaf, it doesn't even need to be a pre-order. It could be, I mean, it's just a simple DFS. But what you do is when you get to a leaf, the main thing is just maintaining a path. So when you're going down, you're maintaining your current path. And then when you get to a leaf, you turn your path into a digit and add it to some certain sum. And then when you backtrack, you pop yourself out of that path, and then you go here and then you add this to the path, so that creates 194. And then since you're at a leaf, you add that. Then when you're recursing back, you pop yourself out of the path, you go down here. So and then you add here to the path. Since you're a leaf, you add 40. So that's kind of the solution there. Does it need to be a specific time? Iterative. Why are they talking about iterative? Recursive pre-order. So, it looks like it has to be a pre-order, but you could probably make it work. What's the most optimal way? O of n and O of 1 space? How? No way. This real? We could trade in performance for space. I don't know how to do a Morris pre-order traversal. I would literally just do this recursive pre-order traversal, and you can see that when they get to a leaf and they're maintaining some, but what they're doing is a bit different. What they're doing is they're taking the current number and timesing that by 10, and then they're adding the current value. That's how you, like, when you times it by 10, you're basically shifting a digit to the left, and then you're adding yourself to it. So that's how they build the digit without, like, using a string. Yeah, because using a string would probably slow it down. Yeah, this is a more optimal approach, I would say. Yeah, I like that approach. This approach is better than the approach that I mentioned before, because then, like, instead of maintaining a path, instead you just times the current number by 10 to shift the digits by left and make space for your digit, and then you just add yourself to it. And yeah, I think that's that's a really good solution as well. That reduces the time it takes to, like, build the digit at each leaf. What else are you doing? Cool. Don't care about that. So the guy, Meta's ass variance. What is this? Hey everyone. I've been a lurker in the LeetCode forums for a while now, but I've recently come out of the damp, dark attic to actually comment and answer questions, specifically for meta interviews. I've noticed a lot of people asking about the common twists or variants of questions, since big tech companies rarely ask LeetCode questions word for word. What is this? Minimum path to make a... Interesting. I don't even know what's talking about there. I think someone's just promoting their YouTube channel, honestly. E4 screening results. Someone's just asking what the results are. I mean, after you do your interview, just let it go at that point, honestly. I was informed, but new headcount will be released in January, and it shouldn't take long to team match me. I'm wondering if there's people asking. I want to see phone screen stuff. Valid palindrome. First 30 minutes behavior. Second, 2 DSA medium level. So they got valid palindrome and diameter of a binary tree. So for valid palindrome, pretty much to do this is it's gonna be the most optimal way is like a 2-pointer solution, where you have 1 pointer on the left side and you have 1 pointer on the right side, and you bring them in closer, and at each point you're comparing if the 2 pointers are pointing to, like, the same exact character if you lowercase it. So A and A, and then you move it, M and M, that's good. Then A and A. So it's usually a 2-pointer solution. And the moment that 2 of the pointers have a mismatch, you know that it's not a valid palindrome. Because if you just think about it in general, like what is a palindrome? It's something that reads front and back. Like if you reverse it, it's the same as if you read it forward. So that means basically if you compare the first half with the second half, those halves are going to be the same if you read them from one from the front and one from the back. So that's kind of this, and then there's a little bit of extra work to like ignore alphanumerical numbers and spaces and stuff like that. But that's one way you can do this question with O of n time and just O of 1 space. I'm not sure how meta actually cares, if probably they do care about the space, but diameter of a binary tree. How do I solve this? Return the length of the diameter of the tree. The diameter is the length of the longest path between any 2 nodes in a tree. The diameter of a binary tree is the length of the longest path. Length of the longest path between any 2 nodes. Okay. You can do this with a post-order traversal. It's not. The diameter is the length of the longest path. So what you do is you do a post-order traversal, and pretty much at every point, like you go all the way left, and then you go, you do post-order traversal when you look at your left children, and look at your right children, and what your left and right what each child should tell you is like, what is their longest path? What is their longest path to a leaf, right? And then you ask the question, if I add myself to these paths, like if I take how the furthest my left can go to a leaf, and I take the longest that I can go, or my right can go to a leaf, and I add myself to that path, what's the longest path that there's going to be? And then after that, I pretty much take the max of my left and right children. I could show how to implement this. Let me save this, and I'll do this later. I'll do this later in this video. Maybe I'll also do some root to leaves more. I'll do maximum consecutive ones also. And I'll also do some root to leaf numbers also as well. But I'll do this later in the video, or maybe in a separate video, to show y'all how to do it instead of just talk about it. Okay, where are we at? Valid palindrome diameter binary tree, cool. Dot product of 2 sparse vectors, interesting. I've seen this question before. Dot product of 2 sparse vectors. I don't remember it, but yeah, I did that back in March. Given 2 sparse vectors, compute their dot product. Implement with the vectors num. Compute the dot product. Mostly 0 values. It should store the sparse vector. You should store the sparse vector efficiently and compute the dot product between the 2 sparse vectors. So we have like 1, 0, 2, 3. What's the dot product? 1, 0, 0, 3, 0, 0, 2, 4, 3, 0. I'm not sure. I'll do this question later. I'm thinking, how'd I solve this question? The dot product. Maybe using some sort of dictionary. So because we don't want to, because we can easily store all of the elements. Because essentially what a dot product is like zipping these 2 values together. So the 0th element is multiplied by the 0th element here. The 1 element is multiplied by the first element here. Second element, right? So what I could do is I can create like a dictionary of both of these vectors and then figure out the length of each vector. And then I'll just loop through one vector. Like using a hash map will allow us to reduce the number of, or using like a set or something, or a dictionary would help us to reduce like the amount of space because we're not storing like intermediate values. And what we'll do is map an index to a number. So here we'll map like 0 to 1. And then here we'll map 3 to 2, then 3 to 3. Here we'll map 1 to 3. Here we'll map index 2 to 4. And from there, we could probably loop through the one that's smaller and then find the indices in the one that's bigger using like quick O(1) access time because it's a dictionary. And then we just multiply those. That's the way I would do it. Let's see. So the array is not efficient. Okay, yeah. Hash table is the best way. We can also use elements. So this O of n to create a hash map. What is this? So there's another way. You can each index to value pairs. We use 2 pointers to iterate through the 2 vectors to calculate the dot product. I would like to propose an improvement. Yeah, choose the minimum length. And why see the 2-pointer? In addition, he came up. Oh, so they're talking about some 2-pointer solution. What's this 2-pointer solution? You store the index value pairs. You can also represent elements of a sparse vector as a list. I need to do this question. It's just so I could show y'all what's up. So you can also represent a sparse vector as a list of index value pairs where we use 2 pointers to iterate through the 2 vectors to calculate the dot product. Let n be the length of the input array and L1 and L2 be the number of non-zero elements. So, okay, I see what it kind of is. I see. So you just store the index and value pairs. So you'd kind of do something like this. Let me get up my Excali draw, if that's useful. I mean, I'll just do this in a separate video and I'll explain all the approaches here, honestly. So group of shifted strings with uniform character. Modify the logic so that all characters in a string follow the same shifting pattern. For example, ABC shifts to BCD. And XYZ, I did one, but couldn't finish the second. Though I explained, though today the recruit, see, he has updated. Oh, he passed. What is this? Group the shifted strings. Group shifted strings with a uniform character. Modify the logic so that all characters in a string follow the same shifting pattern. For example, ABC shifts to BCD. XYZ shifts to YZA. I see. What does this even mean? Group shifted strings with uniform so that all characters in a string follow the same shift. For example, ABC shifts. Okay. So every digit kind of moves 1. Okay. So what I do is pretty much you can just build a hash map of every single character and what they map to, which would just be the next character under them. You could also like do grab the Unicode number. I forget how to do that. Grab integer from character. Python. What is this? Convert character to ASCII number, I think. yeah, you take the word of each that gives you the ASCII value, and then you can kind of just like minus that by 1 or add 1 to it and do like, if it's a Z, map Z to A, so you'll do like a mod operation. Or you can literally just hard code, like build a hard coded list of pretty much A, B, C, D, F, G, but map like build dictionary that maps A to B, B to C, C to D, and then when you build the new string, you just you just do a string builder where you look at X, and X maps to A in the dictionary, or X maps to Y, Y maps to Z, and Z maps to A in the dictionary, and you build that, join the string completely, and return it, something like that. I haven't done that word stuff in a minute. Where are we? Just open up everything on this. 1, 2, 3, 4, 5, 6. What's happening here? Hey everyone. Recently, including team match. Afterward, reached out and mentioned that they would like to extend an offer, but due to headcount issues, it might take some time. Does anyone have insights into? So new headcount in January. Yeah, I mean, you can't control what you can control. You did good in the interview. Good job, man. But I know like some people, this is their dream job and stuff like that. So I can't just be saying to not worry about it. It's probably, maybe if you don't have a job at all, it's probably a lot of like anxiety. What do we have? Okay, E4. So I have 2.5 years experience and got reached out to about met a recruiter a couple weeks ago. It took 3 weeks for studying during my free time. The interview was 45 minutes long. Interview did brief intro. They did some route to leaf, which no follow-up, just ask time and space. If using, make sure to mention call stack needed in recursive functions. So basically, what's valid word? We already looked at sum to read. So it looks like they're asking a lot of, what? I did this question already too? It's crazy. Valid word abbreviation. So you pretty much abbreviate the word. I see. You try to see if like an abbreviation is the exact same as a specific word. So yeah. So this abbreviation works. So how you do that is, one way you can do that is pretty much extract all the abbreviations out of, like all the digits out of this abbreviation, and kind of do like a 2-pointer technique where you have a pointer on the abbreviation, and then if like, and a pointer here, I and I match, and then you go to the next one. Since it's a digit, just move this pointer up, but increase this one by 12 by 12, right? Now we're both pointing at the I, and then those match. And then we move one pointer up, and one, now they're at the Z. Now when we get to 4, move the pointer 4 up, and now it should match completely here. That's exactly how I would do that question. Yeah, there'd just be extra work of parsing out the abbreviation, but that's kind of how you would implement that. And wow, that's a pretty low percentage. Valid word abbreviation. Cool. Looks like they like to ask that. So I have 4 years and I applied online to a lot of Meta. And the recruiter reached out to me to set up an interview for a product position. The interview was 45 minutes long. Interviewer directly jumped into 2 coding questions after a brief intro. The last 5 minutes was... So it looks like the Meta interviews are about 45 minutes long, and you're going to be asked 2 medium questions. Let's see. The person was asked if if a root leaf has an even number of negative nodes, the generated number should be added to overall sum. If the path has an odd number of negative nodes, the generated number should be subtracted from the overall sum. What does that even mean? We have some. Okay, I wrote the code in a standard tree traversal approach, but also incremented. Okay, it looks like they were asked. Was not asked. Was asked the sum to root thing. Initially says on being asked if there's more optimal solutions, I suggested the quick select. Interviewer said that either is fine, but if I implement minimum solution, a follow up would be asked. But for the quick selection, no follow ups would be asked if the implementation is correct. I chose to do the quick select with a random pivot selection. Space complexity is O of 1 in the recursion stack, and time complexity is if O1 space complexity if O1 if recursion stack is not considered. I mean, recursion stack is usually considered, but time complexity is O of n squared in worst case scenarios where the input is sorted in reverse, and the random pivot selection returns extreme indices. I actually don't even know how to do kth largest element with quick select. What is this? Yeah, I don't know how to do that with quick select. Maybe I'll look into that just because it sounds interesting. Just writing some notes over here, and I'll share all this stuff with y'all. Can do this with quick select. I feel like you in this interview, you can't waste any time like talking about anything. You kind of have to know or seen that solution, honestly, from what I see. This is kind of crazy. They're just asking 2 medium questions in 45 minutes. That's pretty wild. Honestly, I don't even type that fast. I don't know like if I would be able to do this stuff. This is crazy. So good luck anyone interviewing at Meta. What else? Sum to root. Basic binary search. Find the local minimal question. 35 minutes to solve both. Okay, yeah, they're doing the find the. This one is called like. What is this question called? Find peak element. Find peak elements in LeetCode. Find peak element in LeetCode. How does this work? Yeah, or solve this. This is like a modified binary search algorithm. So you modify binary search algorithm. I have a video on this. I'll post a video on how to actually solve this. This looks like a very classic meta interview question, but I'll throw that there. And valid word abbreviation. I mean, we just talked about that. That's not really that easy of a question, honestly. Just give only part of where for pointing out the return value. An example, see your communication. At least for the top 4. Why did you say top 400? That's so much. So it looks like if you're going to be studying, if you're going to be interviewing at Meta, literally just only do tagged questions. Do tagged questions if you're interviewing at Meta. Because that's what it looks like people are saying. And they're just getting straight asked LeetCode questions. Just eyeing it. I wouldn't do the past 30 days. It doesn't seem. I'd trust the past 6 months. Okay. Interesting. Do the past 6 months. Okay, that's number 2. Let's get into the list over here. Wow, it's a lot. Not really interview question. Diameter binary tree. I wonder how do we represent graphs and trees when you want to trace it. I usually do very well with array explanations. I know exactly how to represent the pointers that move in an array and all the important variables that are needed. But when it comes to graphs and trees, I struggle to picturize or represent the example in CoderPad and go about with the explanations. Well, let me zoom in too. What is this? I don't know. Doesn't even look like they're talking about questions here. Buildings with an ocean view. This is kind of pretty easy question. You just work from the back and you figure out a max. And if your building is not bigger than the max, then you just move on to the next index. If it is bigger than the max, you increment the buildings with ocean view by 1 and you update the max. Kind of what's happening here. What else is happening? Asteroid Collision. You could solve this using a stack. So the way you use this, you can solve this pretty much using a stack. Pretty much, if it's positive, you just throw it on the stack. If it's negative, you just throw it on this. Or if it's positive, you throw it on the stack. If it's negative, if it's negative and the one beside it is negative, they're gonna collide, and the bigger one gets taken. So yeah, basically how you do this is you simulate it using a stack. That's the solution, and I can implement that. I'll just share this quickly. I can implement that for y'all. I'm currently preparing for, so also people are saying do last 6 months tagged and not the last 30 days tag. Where are we? Let's move on to page. Oh, let's go. I am currently preparing for meta interviews, and I was wondering if they specifically ask for recursion solutions. I'm not talking about trees or graphs. Let's say we have a string question and we want to solve it using a stack. How long is this? This has already been 30 minutes. Does meta have... I don't even know what's going on here. Valid Palindrome II. Post order iterator for... they had a phone screen. They got this valid Palindrome II. So this is like... Is it a valid palindrome if you delete at most one character? So how you do this is you pretty much do the regular valid palindrome solution. But if there's a mismatch, what you try to do is try to simulate deleting the one on the right and then seeing if that turns into a valid palindrome. Basically, to delete the one on the right, you basically just move the right pointer up by 1 and then you just continue the operation. Or you try to delete the one on the left. So that means moving the left pointer up 1 and then continuing the rest of the operations to see if it's solved. So that's like an O-Ven solution, and that's how you solve this one optimally as well. Let me just verify that 2 pointers. Yeah. I mean, people say it's hard. It's kind of hard. I already seen that. Post order iterator for a binary tree. Similar to, except for post. I started, and they encouraged me to think of a better solution. I explained the iterator approach using stack, and they asked me to implement it. What's a post order iterator? Binary search tree iterator? I haven't done this question before. I'll look into this. And all this, like, I'm literally just building a list right here. I'll show you in a sec. I'm pretty much building this list right here for y'all, and I'll post all of this in the channel, but I'll also do these later for y'all and show y'all how to actually do these problems. So yeah, that's about it. I've never seen this question before. I'm gonna just track it down. Binary search. How do you even do that? You can use controlled iteration in the sense where the next is called, pop out the element and check if it's the right subtree. Interesting. Okay, I see. This is kind of interesting. Post order iterator of a binary tree. So you just do a regular. What you could do is like do a post order traversal of a binary tree using a stack. And every time they call next, then you kind of like pop out that element and return that. And if it has, like, you need to be able to do post order iteratively. So that's also a different question. Iterative. I know how to do this non-iteratively, but they want to do it iteratively, so I'll just store that here. Post order traversal iteratively. Cool. I'll do that later. Makes a bit of sense what they're gonna do there. A lot of people are talking about head count. Lots of people talking about head count. Don't worry, brother. Let's see. Technical round. London position. Valid number. Whoa, that's a hard. They asked a hard question. Which accounts merge? I'll do this one. I'll do this one later. Now, what's this valid number? You're given a string s. Return whether s is a valid number. For example, the following are all the following are valid numbers. Well, these are not. %? That's crazy. This guy got asked that. I'll look into that and figure out how to do that for y'all. In an interview setting? No way. They're tripping. Basic calculator 2. Shortest path in a binary matrix. Did I solve this? Okay, return the length of the shortest clear path in the matrix. A clear path is a path from the top left cell to the bottom right cell, R0, and all the adjacent of the path. Okay. Here you can kind of do like a breadth first search in order to find the best path, because breadth first search, do BFS, because that's BFS is the fastest way to get the shortest path in a graph where all the edges have the same weight. So let's see. Yeah, you do a breadth first search here. I'll do this question for y'all separately. But it looks like all they do is a breadth first search. Yeah, just do a breadth first search. Have I done this before? Back in February? Let me look at my code quick. I think I just do a very basic depth first search and grab the neighbors. Yeah, you just do a depth first search and you stop when you get to that specific element, or when you get to the very right and the very right is actually a 0, then you could just stop. So it's just a breadth first search solution. I probably won't practice this for y'all because I would just study breadth first search. This is a good that's a good breadth first search practice. What else? Basic. Tragic. Basic calculator. This is, you can solve this using a stack. So use a stack, parse out the input and remove the spaces, or you can probably that's one, like do one pass to format it nicely. Then finally, like format it nicely and build all of the digits into, like, if because you can also have multiple digits like 5 2 2. So build a stack where pretty much the stack, or like parse the input, so pretty much the input is just an array of like each digit and each operator kind of in their own index, and also like join like big digits into one digit, or like multi-digit numbers into like one number in the array, and then run your stack operation on it. And in your stack operation, make sure you capture the divisions and multiplications before you do the plus and minus. So usually you do 2 passes. You do one pass to capture all the divisions and multiplications, and then finally you do one last pass to do like subtractions and or additions and subtractions, so you can follow like the BEDMAS principles. That's how you do basic calculator 2. Moving on to the next. Vertical order traversal of a binary tree. Minimum. Dude. What is this? This is a kind of hard question. Vertically traversing a binary tree. I think what you need to do is just do a regular DFS at first to group all of, essentially what you want to do is group all of the nodes in whatever column they are. So how you can do that is set the column that they're in. So this is in column 0, this is column -1, and then over here this is column 1. So if you just maintain what column you are, when you move to the left you can -1 from your current column, and then when you're moving right you can add 1 to a specific column, and that's pretty much how you'd be able to like kind of group up all of the nodes in their specific column, and then from there, when you have them in their specific column, I think, yeah, you just kind of return that. You can build like a hash map of all of the different columns, and like all the different columns. So this would be -2, -1, 0, 1, 2. These would be 0. But the trick is to maintain a column, and then like when you move to the left, subtract from that column and let this guy know that they're in column -1. And then pretty much like when you go to -2, you subtract from that column as well. And that helps you group nodes within, like, that helps you group nodes under a specific column. And after nodes are grouped up in a specific column, like after your nodes are grouped up all in specific columns, essentially now you just need to like parse those columns, and they're probably going to be in the same order if you do like a pre-order traversal. And yeah, you just parse it into this final output. I can show you the logic for that. There's just way too much questions to do. This is going to take up a lot of time, so I'm going to need everyone to go like hit the subscribe button if you're going to use this to help you pass your meta interviews. Let's see. Minimum window substring. Given 2 strings S and T, length, return the minimum window substring of S such that every character in T, including duplicates, is included in the window. Have I done this question before? So, such that every character in T, including duplicates, is included in the window if there is no such string. So this is another sliding window technique, but obviously a bit more extreme, where pretty much you grow the window. Let's see. You kind of grow the window. How would we do this? Minimum window substring such that every character in T is included in the window. I don't even know how to do this. It's a sliding window. Okay, they say it's a sliding window. I need to spend some time on it. Then there's an optimized sliding window. I'll take a look at this after. I'll do this question later. Let's see. Move here. Oh yeah. I'll add this in my priority of things to solve. Looks kind of hard, but some sliding window variation, if you ever asked that. No way this person had to do 2 hards for a phone screen. Well, I solved this before. What's happening? Valid Palindrome II, we already talked about that. Top K frequent elements, same as the follow-up. Must be better than log n, where n is the array size. Specifically ask about the n enclosed case and how we can solve this. Top K frequent elements. What is this? Yeah, I think here you have to use a heap. Can you do quick select here too? What? Okay, I need to really look into this quick select. I'm putting this as my main thing that I need to study. This damaged my brain. That's wild. So this person's stalling. Interesting. I got a call from a recruiter who submitted my profile in Sui and did not try to write a function for the following array. So this is like a recursive thing. So 7 plus 1 plus... Yeah, this is nested list weight sum. I've seen this question before too. I'll add this in a list of questions that I'm going to share with y'all. Behavioral power. Minesweeper. I didn't know they had a Minesweeper question. Nice. This is cool. I've been asked this in interviews before. I want to implement this. Minesweeper. I've been asked this in interviews before, so I'm going to save that because I like this question. Someone got asked Minesweepers in a meta interview. So let's play Minesweepers. You're given... Return the board after revealing this position according to the following rules. So essentially all it needs to do is you just take in a click, one click, and then you just simulate what happens. Did it unveil a mine? Or like if you click something, is it going to spread, I think? That's kind of what you need to implement here. And to spread it out, just you can do like a BFS or a DFS, whatever you want, to like when you click a cell to kind of like expand it out. What's this power function? Oh, this one's kind of hard. Essentially what you do is, yeah, this is kind of hard. I'll just show you the solution. You do this binary exponentation. I don't even know how to pronounce that. But essentially you go 2 times, you just like make use of the power laws to kind of reduce the thing without actually doing a multiplication. So you do 2 times 2 is actually equal to, or 2 to the 100 is actually equal to 2 times 2 to the power of 50. And if you multiply those, 4, you get, and then you get 4 to the 4 is equal to, or if you multiply those, you get 450, right? And then if you do 4 times 4, that's equal to 25. So that's kind of how you reduce, you do like binary exponentation in order to get it down to the actual value. That's kind of a hard question. This person does it recursively, but you can do it iteratively to reduce the amount of space. Honestly, I'd probably do it recursively if it's easier, but you can do it with, one space. What else do we have? None of them need more than 10 or 15 lines of code. The interviewers were there to help me. Interesting. Okay, cool. Let's move on to page 3. Be right back, gonna take a quick break. More questions, let's go. Page 3. Pop these open. Kids are grinding their butt off. Good job. Keep it up. Keep it up. November 27. Menlo Park. Phone screen. Solved and described all tasks, but due to my good experience of solving such problems, the interviewer had problems with the internet connection and was disconnected a couple of times. The recruiter was surprised that I was not selected, so it sounds unusual in this case. Find the median in a sliding window. Given an array of numbers in a sliding window of size k, find the median of each number as it slides from left to right. That sounds complicated, but it's pretty much not. You just, is it hard? That's crazy. I thought you just use a queue and you divide it by the length. Use a queue here? Did I solve this before? Use a queue, simple sorting. How do you do this? 2 heaps. That's crazy. I don't even know how to solve this question. I know how to find the median in a data stream. Where is this? Wow, these are hard questions. Man, I'm sorry you got asked this. I'll solve this later. So, find the k closest points to the origin. Given an array of points in 2D plane, return the k closest elements to an origin. Can you do like a quick select here, or you just use a heap? Use a heap. Max heap. Binary search. Okay, so this is kind of like this it's like the quick, with these top k, you can use this quick select, which I'm literally not familiar with for that, so I'm going to look into this. But what I'll do is you can calculate the Euclidean distance and then just store the k most in the heap, and then pretty much at the end pop out those k like largest. Interesting. Not, those are two very hard questions to be asked in a phone screen. I feel bad for you. Yeah, I feel bad for you, man. Did you talk? Yeah, that sucks, man. First easy problem. I'm not sure. Odd even where you sort them. Interval list intersection, but it was about flights and their stops. A graph problem. A two-pointer problem. So, median of two sorted arrays. That's a really hard problem. That's a really I don't even know how to solve this median of two sorted arrays problem, and I've already like watched like 10 different solution videos on it. So interval list intersection. Yeah. I know. You have to, yeah, to solve this, basically what you do is you basically throw all of the elements into one array and sort it by start time, or you generate an array. What did I do? I sorted it, but what you can do is pretty much generate a combined array by just using like two pointers to link them, or you can just do a two-pointer solution in general, and if they overlap, then you just capture where they overlap, and then you move up the pointer that's smaller than the other one, probably. Yeah, you move up the pointer with a smaller end time than the other one. But can we assume that these are already sorted? You're given a list. Yeah, because you already assumed that it's already sorted. Then you could just join them. You can merge the intervals. What is this? Move the interval with the smallest endpoint. Yeah, you move up the interval with the smaller endpoint. Because maybe one... So, yeah, you kind of... It's like a two-pointer solution. Damn, this is kind of hard. I solved it too, but mine wasn't really that optimal. And the more optimal way is just use two pointers and move one up. Compare the first two values. If they intersect, add it. And then move up the one with a smaller end time. Interesting, interesting. This is gonna be a long video. Let me see if I can like tank out the first like 10 pages. I'm gonna like pause it midway through and stuff, or like I'm gonna have pauses and stuff, because if I get tired. So I'm not sure what this problem is, but it was like an odd even problem where you have to sort them based on if they're odd or even. Okay. Interval problem, we just looked at that. Pacific Atlantic water flow. Yeah, this is like a graph question, but you kind of want to work from the outsides and then see like how far water can reach in, kind of thing. So that's the trick to this one, like work from the outsides. You could see you kind of work from the outsides and then see how far you can get in. And then you just capture the intersection, like any of the ones that you can reach from both oceans are like what you return in the result. But the key here is to work from the outside, like work from these oceans inwards and not like from specific nodes. Best time to buy and sell stock. Is this a 2-pointer solution or just a 1-pointer solution? I think you could. I think all you need to do is like do a 1 pass, but also maintain the minimum. And while you're moving through it, when you just maintain the minimum, and if you're higher than the minimum, calculate that value, and then just keep storing the minimum value. That's an O of N approach with O of 1 space. So yeah, min price, and you just do 1 pass. What else did this guy get asked? Custom sort. Did this person pass? Okay, whatever. Custom sort string. What is this? You're given 2 strings and all the characters are unique and were sorted in some custom order. What do I do here? You pretty much sort based on this custom comparator. Interesting. What's the code to this? So there's an O of N approach. Why did I do an N log N approach? You're given 2 strings, order S, and all the characters of order are unique and were sorted in some custom order previously. Permute. My brain stopped working. So that they match. Permutation, so it's permute the characters of S so that they match the order that order was sorted. More specifically, if the character X occurs before a character in Y, then X should appear before Y in the permutated string. Return any permutation of S that satisfies this property. Okay. That's probably why you can do a counting sort, because you can kind of like so the order is here. So if you see A, so A you know is the 3rd. So if you see A, automatically just put it at the 3rd index, right? And if you automatically see B, put it there. C, because you can do some sort of counting sort. I need to look at this more, probably separately. This is interesting. You could this problem you could actually solve an O of N minus N log N, where we kind of just figured out the order map. And then we just ran a sort based on the order map, and then we just returned the results. But that's not actually optimal. But we need to cover the left side, the bottom, right? Bottom, and then... So Asteroid Collision, binary... Okay. Dude, they're asking some hard questions, honestly. I need to work on my leetcode skills. Just completed my initial screen with meta for E4 sweep position. The questions I got were merge sorted array. Okay, the way you do this is with pretty much 3 pointers. You create an output array. Or you do 3 pointers. You don't need to create an output array, but you have 1 pointer here, and you just take the biggest value from the 2 ones, and then you move it here, and then you, depending on which value you take, you reduce that pointer. So it's a 3-pointer technique to get that working. Draft BFS. What is this? Just got done with my new grad role. It was actually due to NDA. You're already anonymous, brother. 3.9 GPA student. Good job. One sec. Pausing quick. Started the interview, dove straight right into coding. The first question was, which I easily identified was valid palindrome. Solved it through using for loops and string, basically time complexity is O of n. Finished off the valid palindrome. Then the interview asked follow-up questions, how we can change this in time and complexity. Made some changes to code. It was like log. What is it you're talking about? The only way to check a valid palindrome is O of n, optimal time, using two-pointer solution. Yeah. Binary tree zigzag level traversal. Yeah, I know how to do this. You kind of just do a level order traversal, but each level, you kind of like work backwards. So from this level, you move from left to right. From this level, you move right to left. And then from this level, you move, yeah. You can do, that's one way to do it. Just switch the order that you're going to do. Like a regular binary or regular level order traversal. But pretty much you move from like one way to another, essentially. Or like you swap the direction that you're going to go. If you store each level in a sort of like a queue or something, then you could like when you're moving from left to right, just append to the queue. But when you're moving from right to left, like append to the front of the queue instead of the back. So when you're moving from left to right, append to the back, and when you're on this level, append to the front, and then you'll get the solution if you just do one more pass to parse out the inputs. I think that's the most intuitive solution to do that. Let's see. Yeah, it looks like they used the same thing. Oh, okay, you use a delimiter to mark the level. And I don't even know what they're doing right here. Dude, people have come up with some crazy ways to do this. Yeah, I would solve this the way I would do the level or vertical order traversal. Looks like they just want you to traverse trees in every single possible way there at Meta. It's kind of interesting. What else? Start. Yeah, you can't do that in log n. You can't do that. That doesn't even make sense. I just finished my meta screening round. I provided the code for both solutions. The questions were custom. Least common ancestor. What's least common ancestor? Lowest common ancestor, you mean? It was least common ancestor 236. What is this question? Code 236. Lowest common ancestor of a binary tree. You could do this with a post-order traversal. This is like a classic question, but I'll write it down for y'all. Custom sort string, we covered that already. There's an O-Van solution for that. I was asked 2 questions from LeetCode top 100. Custom sort, least. Okay, I got asked the same stuff. Business engineer, E5. Subarray sums equals K. What is this? Given an array of integers, return the total number of subarrays whose sum is equal to K. Whose sum equals to K. So I think this is a sliding window solution, and when the window gets over K, you like remove an element from the, like you shorten the window, and you expand if you're under K. So it's a sliding window. Let's see. Using hash map. Using cumulative sum. Oh, wow. Okay, I see. I've done this question before. I know what this question is. You use a cumulative. Gets very interesting. You store like a prefix sum, and then you see how many prefixes in the past. If you like, oh, this is a hard question. Underestimated that. Subarray sum. I'll cover this in a different video. This is actually a good question, and I'll cover it in a different video. Dude, there's so much things to cover. But you pretty much do this is my code. You do like a prefix sum, and then you basically calculate, like it's almost like two-sum where you're storing all the different prefixes you've seen. And you increase to your current prefix sum, but pretty much at every element, you see how many prefixes that if I subtract that prefix away from my current total, I'll get to 2. Like I'll get to K. So it's not a sliding window. It's more of just like O-Van solution. Like a very, very tricky, smart O-Van solution. I would not ask this personally in an interview if that was me doing the interviews. Palindrome permutation. Given an easy string, return true if the permutation of string could form a palindrome and false otherwise. So to do this, pretty much it would need to be, if it's an odd, basically what needs to be is all characters need to have need to show up an even amount of times, except for 1 at most, right? But like 1 could be odd, but that's the worst case. So it could be all even and 1 odd, or just all even. Using hash map to count the frequencies. Maybe I'll ask this to my brother. It's actually a good question. Dude, there's so many questions for this. It's O1 because the set can grow up, can only be... Yeah, because it could only be like at max 26. Simplify path. I have a question. I already like solved this. It's a stack solution. I already have this in my like a video on how to solve this question. I solved a lot of these FANG questions because I'll be uploading all of them. So anyone trying to do FANG interviews, I'll hook it up. Subarray sums equals K. Valid number. I don't even know what this is. Oh, that one's hard, man. I'm gonna check that out later. I recently got an offer from Meta for a new grad role. I want to get back to as it helped me. I got an OA from Meta, which I passed for. 2 questions were of LeetCode easy, 1 level medium, and another was medium-ish hard level. I got an interview about 1 business day later. I had 3 technical interviews honestly, coming out as a new grad and being able to solve medium and hard level questions is crazy. Good job. Kth largest element in the array. Kth largest element in the array. What is this? This is the quick select thing. Min heap or quick select. Max consecutive ones. This is the sliding window solution. So you can see that I'm kind of able to starting to remember the solutions. I just need to go ahead and implement them. But kind of in these meta interviews, you got to be able to pull out the question from scratch right away. Basic calculator 2, lowest common ancestor. Binary search question, similar to Cocobana. Largest number optimally, largest number. I don't even know. I don't know what this person's talking about. I got asked 2 medium questions with a follow-up for each one. One of the follow-ups was marked as hard. Generally, I did very well coding both questions and answered correctly for the follow-ups, but confused with complexity analysis. It's been more than 4 days without hearing back. They're pinging the crap out of the recruiter. So I already did solutions on this one, but if you have the parent node, you kind of treat it like linked list and work from those nodes. You basically need to see the intersection between 2 linked lists. That's the way you solve it. It's kind of a weird solution, but you take one pointer and another pointer, and then you pretty much make them go until one reaches the end, and then you make the one that reached the end start at the same point as, or start at the start of the other one. And then when the other one gets to the end, you make it start at the start of like the other node that you're looking at, and then finally they'll eventually reach like some node, and that node is the middle. So you kind of just have to like swap them. Finding the intersection between 2 linked lists is kind of complicated, and I wouldn't expect someone to figure that out in an interview. But lowest common ancestor of a binary tree is a very classic question. So just study that, honestly. And these are more like, seems like meta is really asking just classic questions. I'm not saying they're hard. I mean, they're not hard. They are hard, but they are classic and not like random ones that they just came up with. Valid Palindrome 3. How do you solve this one? I know how to do valid Palindrome 2, which is just, like I mentioned, you can delete one. But how do you, maybe to do this, you can use dynamic programming on specific indices, and then basically you figure out if those 2 indices can actually lead to a valid palindrome, and then you kind of store that. What's in their memoization table though? Bottom up DP. What's in their memoization table? I don't know. I'll cover that separately. Looks like they passed. Got two questions. How good is this person? How much questions do they solve? Nice. 336. Good job. Good job. Good job. What else do we have? Valid palindrome. Reverse a linked list. This is classic. This is classic. Reverse a linked list. Classic. I'll just writing down my list. Look, this list is getting long of all the different ones, but don't worry, I got y'all. I'll compile this and make sure y'all are all prepared. You know what's going on. They're not asking anything. Page 4, let's go. Getting through this. I'll probably chop this up into like 2 different videos and do like from page 4 to 5. Or yeah, this is already getting so long. I'm starting to see the trends though. So this is like, if I was gonna study for like a Meta or like a Google, I would actually do something like this, and I would just spend a few sessions actually looking at these questions and seeing what people are asked. Longer. Oh, that sucks. Well, I'm not as sad. It's disheartening. Get up. Yeah. Don't worry, man. There's so much good companies to work for. Kth largest element minimum. Yeah, already seen those. Sliding window maximum. So given an array of find the maximum. Who's this person? Nice. So cool. Yeah. To this, you can kind of use like a queue where I know how to do this. Sliding window maximum. I'll show that in a different video. There's a classic. Oh my god. Is it actually that hard? Oh yeah. I was thinking sliding window like mean or something. How do you solve this? Yeah, I'll just write this down and get this solved for y'all. So we've already been asked sliding window median, sliding window maximum. They like these sliding windows, so it looks like it's a bit of a trend. Right side view, variation of intersection of intervals. Messed up here as it was a merge intervals, but with 2. Okay, already seen that. Lowest common ancestors of binary tree 3. We already looked at that. It's basically find an intersection of 2 linked lists. Find peak element. The best way to do this is through like a binary search, modified binary search. NVIDIA versus Meta. Take whatever you want, man. They're both good companies. Just getting some text. Know what this is? Questions was one of the tagged. Don't know what this is, but let's end it. At least you just got done. For E408, only prepped for about 1 to 5 months, and even then it was... So people are... It's starting to drop off a little, and people are just asking questions that aren't really that relevant. Yeah, I think I don't want to go through any more of these pages. Maybe let's look at 5. Let's like switch it to not just, let's just do meta, but then do most relevant, and then look through the first like 5 pages for that. Then I'll finally compile this list for y'all, and we'll call it a day. Yeah, got it loaded. Be right back. Let's keep looking at more questions. Word search 2. What? No way. Word search 2. Hard question. Interesting. This is like you use like a backtracking algorithm, but at the same time they use the backtracking algorithm, you also couldn't like use a prefix tree. So use a prefix tree with backtracking. So implement a try. Yeah, backtracking with try. Is there a more optimal solution? I mean, that's what I would do. Backtracking with try. That's rough. Whoever had to do this, I feel bad. I haven't done that question in years. So you're given an integer number. You can swap 2 digits at most to get the maximum valued number. Return the maximum valued number you can get. So I would just swap. I would swap 1 digit. Pretty much what I would do is, I mean, the first way is it's like this. It's like the next biggest digit question. But first, find out if there's even a bigger number, and how you can do that is like if this is decreasing from left to right. If this is like monotonically decreasing from left to right, then you won't be able to find another one. If it is not monotonically decreasing, what you'll do is you'll take the element, the most significant digit, and you'll try to swap it with the biggest number to the right of it. And then once you swap that, you're pretty much good. From right to left. I don't even know how that works. What? Does it need to be that complicated? What even is this? These are 2 new questions I didn't see. Maximum swap. I need to look at this. So you do the largest. No idea what this is. I'll do this later in a separate one. Did not move to art, so I'm ready for the other environment. Years of 7 years experience, around 200 LeetCode questions. Got meta interview call through a referral. Prepped for 1 month. Mock 2 LeetCode easy, intentionally easy to ease into the process, I guess. Phone screen 2 mediums from 6 months. So it needs to be from the 6 months most frequent list. 1 medium and 1 hard. Explained the optimal but couldn't complete. 1 easy, 1 hard. Okay. Can't share exactly, but all of them are FB tagged. So it looks like if you just follow the Facebook tagged, you should be good. You should be good to go. We're from the 100 questions I solved. This person solved 100 questions from the 6-month list. They were really going hard trying to get from this job, getting at this job. tried. Interesting. Meta. There are 2 questions asked. Given a string with duplicate characters, return the maximum length duplicate contiguous characters. What? Given a string with duplicate characters sequences, return the maximum length duplicate contiguous characters. I don't even know what that means. Find the kth missing item in the sequence, given the longest increasing. Those are kind of hard, man. I don't even know what they're asking. I'll save that for y'all. What? Talk about actual questions. People are just asking stuff. Diameter of binary tree, we already covered that. Kth largest element in array, we already talked about that. You need to learn quick select. Phone call. Given an array of size n, check whether the array contains numbers from 0 to n minus 1. So these are all meta tag leetcode questions. This is kind of old in 2013. Interesting. Let's move to number 2 here. These are a lot of these are old. I mean, let's just look at the list of the top 75 questions right now, and then kind of I'll take you all through that. Problems, meta tag. So if you want to do meta tag, just go pretty much last 6 months. You can see all these questions. I've done a lot of leetcode questions, so all these are kind of solved here. Oh, they got asked 3 sum. Letter combination with a phone number. What is this? Oh, there's like some backtracking algorithm. I need to solve more leetcode questions. I've solved some of these, but it's been a while. After you pass the recruiter call with Meta and schedule a phone screen, you'll be able to schedule a mock. It's the same, except it doesn't count as they just give you feedback at the end. Interesting. I didn't even that. So anyone interviewing there, you can schedule a mock interview. So we covered this. Minimum remove to make valid parentheses. Use a stack. Valid word abbreviation. Use 2 pointers. Valid palindrome. Use 2 pointers, 1 on each side. Binary tree vertical order traversal. Pretty much here, just figure out which column that you're in. This is 0 column, this is -1, this is +1. And yeah, pretty much based on your column, make when you pop the left one in, give its column -1 your specific column. So this becomes 0, -1, -2. And that will group all of these up in their columns. And if you do just a depth first search, it would naturally just also group them, or like each column will actually be in the proper order, and then you just finally print that out at the end if you know like the minimum column and the maximum column here. Kth largest element in an array, as we mentioned, that involves what's it called? Kth largest element is a quick select. You can see here. Quick select. Basic calculator 2 is a stack. Lowest common ancestor of a binary tree number 3. that is using like is basically finding the middle or finding the intersection of two linked lists. Merge sorted array, 3-pointer technique. Lowest common ancestor of binary tree, that's just classic question. Find peak element binary search. This would be exponentation or something like that. Binary exponentation, look that up. Pretty much what you're doing is you're reducing the exponent by multiplying the two bases by each other and reducing the exponent by half. Because, yeah, and then you multiply these and you get 4 to the 50, and you kind of do that till you get to like a base of 1 here. And you could do that recursively or iteratively. Range sum of a binary search tree. You basically get given, what did I do? You could just do a pre-order traversal here. What's the answer? Yeah, they just do a depth first search. Simplify path, use a stack to do this. Dot products of two sparse matrix, use 2-pointer solution. Shortest path in a binary matrix, use a queue. 2-sum, use a hash map. Binary tree, right side view, do a level traversal, but only grab, like, for each level, or just grab the very right element. Merge intervals. Yeah, you can pretty much use a stack kind of thing where you sort everything by their start time and then just start merging and then just start building the result. And then since everything is like, the key here is sort by start time, and when you sort by start time, you'll start to get overlapping elements adjacent to each other in the array, and then you just merge those. Kind of like a stack question. Valid palindrome, use 2 pointers. Subarray sum equals K, use a prefix sum solution. Diameter binary tree. What is diameter? So this is use a post-order traversal here. K closest point to origin, quick select or just a heap. I use the heap here, but quick select is more optimal apparently. Copy list with random pointer. No idea what this question is. I've never done this before. I'll figure that out for y'all. LRU cache. This is like a classic question where you use a doubly linked list. The fastest way to do this is using a doubly linked list. I probably May 11. Yeah, use a doubly linked list here. And it's kind of like a queue, or you use like a linked hash map. A hash map contains references to all the nodes, and then use a doubly linked list to easily move elements from like any point in the linked list to the back. So you kind of want to maintain a queue, like a linked list hash map kind of data structure. This is a classic question, gets asked a lot. Next, permutation. This question is annoying. Essentially what you do is you basically need to find the next permutation that's just larger, lexicographically larger than like the current one. So 1, 2, 3, the next if you use the same, like the next permutation that's larger than the current one. So one thing you'll know is if a thing is monotonically decreasing, there's no more larger elements. So if there's no more larger elements to this element, what you can do is essentially just sort the array, or just reverse the array if it's monotonically decreasing, and that'll give us the result. Otherwise, you kind of have to work from the back, and the moment you see like a decrease, you essentially swap this one with like the largest element to the right of it, or not the largest element, but the next element larger than it to the right of it. Once you swap that, you pretty much reverse like the end, or reverse from like here. Yeah, pretty much reverse like the back half. And then the reason you reverse the back half is so that it becomes an increasing order. And usually in increasing order, that's like the next smallest number. That was a mouthful. I'll drop a video on that as well. Convert buildings top k frequent elements. I mean, this is the quick select question. You can use a heap, and the most optimal approach is a quick select. Buildings with an ocean view. Pretty much work from the back, maintaining a max of what you've seen. So pretty much for this one, work from the back, maintaining a max. If you're larger than the max, increase the count of buildings with an ocean view, but then update the max. And then pretty much anyone who updates the max is somebody with the ocean view. That's the code right there. Merge k-sorted list. Convert a binary search tree to a sorted W-link list. I don't remember how to do this. I think all you need to do is an in-order traversal. When you do an in-order traversal, just keep element of the left and the right. Yeah, do an in-order traversal. What I did, it's probably not optimal, was an in-order traversal where when did I solve this? I did an in-order traversal and I appended the result. Basically what I did was an in-order traversal where I just made a list of all of the elements. If you do an in-order traversal, it will put the nodes in the right order here, and then you just have to like link them at the end. And you could probably not build a full list. You could probably just do it. It might not be like they both use the same space, so I would just usually do my approach where you just do an in-order traversal to build the list, and after you have a list, you kind of link each adjacent element to each other, except for the first element. You link it all the way to the back, and the back element, you link it to the front. Dude, there's so many questions here. Yeah. I don't want to go through this. I think you're getting a sense of exactly what we need to do here, and this video is already an hour 45. So maybe I'll cover these top 6 months question in a different video. I don't even know if this is copyright or something like that, but these change. Go buy your LeetCode subscription. It's the most useful thing I've ever bought in my life. So yeah, I'll see y'all in the next video. Thanks for watching. This video is pretty much going to be like, what is meta asking in interviews these days? All right, see ya.